So hello friends, I am going to discuss about the applications of Poisson and chi-square distribution for comparative analysis of accident frequencies on highways. The paper is presented by myself and my colleague Professor Bangal. We are from Department of Civil Engineering, Government College of Engineering, Aurangabad. Basically, the laws and enforcement, drivers, road surfaces and vehicles, they are the areas which are responsible for road accidents. Now in this paper we have established the relation between the deaths per motor vehicle and vehicles per head of population and international comparison of road accidents. So this is the comparison. The number of accident figures that we have shown in 1991 to 2000, they are fitted in number of motor vehicle N and the population P, and the number of deaths per vehicle population N in relation in the form of item, that is D by N is equal to 0.003 N by P minus 2 by 3. This is the equation and this is the notations. Now here there are the graph between the 90 to 2001, the number of road accidents, number of fatalities, number of injuries and total casualties reported. Now the collision condition diagram. So at the road intersection, the collision diagram, it is like this way, and the condition, that is either it is a conflict points, so at right angle or the rear collision or front collision. The analysis of accident data. So these are the interplanes, varieties of the factors, regression methods, Poisson distribution, use of chi-square test for comparative comparison of accident data, multivariate analysis, quality control methods. So these are the accident rate and the severity during the 1995 to 2000 in Aurangabad district. So these are the road accident severity in terms of fatality during the 1995 to 2000 Aurangabad-Jalna state highway. Then this is the road accident severity in terms of grievous injury from 1995 to 2000 in Aurangabad-Jalna district, Jalna state highway. Then road accident severity in terms of minor injuries 1995 to 2000 on Aurangabad-Jalna state highway. So Poisson distribution, the formula is P of R is equal to E raised to minus M raised to R divided by R factorial, where PR is the probability of occurrence of R events, M is equal to NP, that is the average rate of occurrence of events, and E is the base of Napoleon logarithm. Subjected to N is sufficiently large, say N is greater than 50 and the P is very small, that is P is lesser than 0.1. Applying the above formula, let N is the number of drivers, M is equal to kilometers driven by each driver, probability of having an accident per kilometer traveled, and M is equal to average rate of occurrence of accidents in the length of M kilometer, M is equal to PM, then the probability of N drivers having R accidents. PR is equal to N into E raised to M into M raised to R upon R factorial. So these are the data for the application of Poisson distribution for predicting the accident occurrence. The case study is Aurangabad-Jalna road. So the tabular form are as average driving by the driver kilometer per year, number of accidents per vehicle kilometer, driving career in number of years, kilometer driven by each driver, M is equal to PM, and the probability in percentage of accidents per driver during the career. Then application of Poisson distribution when the data of accidents are available. So this is the normal distribution, number of occurrence of accidents and the probability in percentage. The probability variation, number of accidents per driver during the career was found marginal, and the probability occurrence of 10 accidents per year was found 12.540%, that is maximum value. Chi-square test for comprising accident frequencies. It is the test is useful for the statistical tool with many applications are as follows: testing of proportions with the contingency tables, goodness of fit test, then the probability density function for chi-square distribution, and the graphical representation form corresponding to each degree of freedom there is a definite curve which gives the value of chi-square for various degrees of freedom and the significance level. A convenient application of chi-square test is in the testing of compatibility of observed and expected values in two ways table known as contingency table. So chi-square value observed from the comparison of the actual and expected value is found as chi-square observed is equal to summation of j equal to 1 c is equal to oj minus ej whole square upon ej, where oj is the observed value of the jth cell, ej is the expected value in the same cell, c is the total number of cells, and the degree of freedom is given by nu is equal to m minus 1 into n minus 1, where nu is the degree of freedom, m is equal to number of columns, and n is equal to number of small n is equal to number of rows. So these are the chi-square value is observed as 1.695. The distribution of chi-square for various degrees of freedom. So this is computed value of chi-square distribution for 95 to 2000 is given as under. So chi-square for accident occurred during 95 to 2000 chi-square values are there. Composition of severity of accidents. So this is the violet color indicates the fatal, maroon color indicates the grievous injury, and the yellow color, pale cream color indicates minor injury in 95. So this is the same train, similar train or the similar composition is in the 1997. So composition of severity accidents. So this is 1999 and this is for the 2000s. So conclusion is, it is concluded that the Poisson distribution and the chi-square distribution are effective tools for the comparative analysis of accident frequencies. The Poisson distribution is widely governed by the law of chance, and the occurrence of accidents is a rare event in time or distance or amongst drivers. It was seen that there is a good agreement between the observed data and the frequency to be expected. The goodness of fit test could be treatment for later study. Thus, the chi-square distribution could be precisely recommended for analysis of accidents, as the test results show the compatibility between the observed and the expected values. The chi-square test is a tool for precise assessment of occurrence of accidents before and after the improvement of the road conditions. So 3 E's and 8 S measures. So first one is engineering measures, education and enforcement. Similarly here, speed, then side distance, heat resistance, super elevation, signals, surface conditions, safety belts and social conditions. These are the 3 E's and 8 S measures for the measurement of road accidents. Thank you. Thank you one and all.